I am here in the house where Charles Darwin did his great work on evolutionary biology, and we've just seen a copy of the Times of 1859 reviewing his book, The Origin of Species. And I'm here with Paul Flather and with Perry Marshall. And it's extraordinary to be able to come to the very place where Charles Darwin did all of his great work, his various books and publications. What's your impression of all of this, Perry?
Well, my impression is that there's kind of a romantic notion of Darwin, who, and I think a lot of it is kind of a sense of overturning myth and superstition and getting us on to real science. And I think one thing that's usually missing from these conversations is how what would the word be, how tentative Darwin was
exactly
about most of his pronouncements.
He felt forward, didn't he?
Yeah.
Progressively, with all kinds of doubts in his own mind. And I think he only in the end published The Origin of Species in 1859 because Wallace, who was out there in the Malay Archipelago, finding much the same theory, selection, natural selection and so on, was hot on his heels. That's what made him publish eventually. Yes,
that's true. I think one of the things that does strike me walking around is how much hands-on Darwin was.
He wasn't he? Yes.
You can get lost in thinking that it's all about sitting in your study and just imagining these wonderful concepts and so on. But here he is out in his greenhouse looking at these kind of carnivorous plants, or experimenting with primroses, and just seeing him, him getting his hands dirty, literally.
Exactly so.
And I think that plays to this point of taking time, because, he'd have to watch plants slowly grow and measure their changes and establish the kind of difference, measure the difference in little plots of land. It takes time.
It takes
patience.
Time. And I think he learnt this also in that 6-year voyage of the Beagle, all the way down the coast of South America to the very tip, and then all the way up again on the Pacific side to arrive at the Galapagos Islands, and did the same thing, which was to look at all this, carefully note it, put it down, put it in together with the stuff he took back with him to England. And it was only when he got back to England that somebody said to him, hey, wait a minute, each of the islands has a different kind of bird beak. Darwin himself, he says this actually in his letters. I am a rather slow thinker. But I think that slowness was also his great virtue. He didn't jump just for the simplest explanation. He was a very, very careful
And even after there's quotes, isn't there? Even after he'd written his great work, he said, when people criticised him, he said, "Oh well, I was a bit rushed.
That's right. Exactly.
I probably should have taken more care on this section."
Well, he started revising,
quite
and that's why much later, 1868. So nearly 20 years is that after? No, 1859 to 1868. It's only 9 years, isn't it? But 9 years later, he starts thinking about the question, could there after all be a way in which the body could tell the germline to communicate down to the progeny some of the characteristics that had been acquired? And he invented his theory of gemmules. We discovered them. You and I, Perry, have discussed this. It's just remarkable. I mean, it's as big a discovery as the discovery of capillaries after Harvey said there is a circulation, but he couldn't see where the two bits connect, how did the veins and arteries connect. So he said there has to be something there. It has to be just that we can't see it. And that's exactly what Darwin said, which is there have to be particles that pass all the way down to the germline. We just can't see them. They're too tiny. Now, the interesting thing is Lamarck said exactly the same thing. He didn't call them gemmules, he called them subtle fluids. But that's exactly what he meant. Precisely the same.
Well, I've had a lot of conversations with people about evolution, and I've talked about how there's a revolution going on in evolutionary biology, and I have some people say to me, there's like no other theory of evolution. There's just always been the theory of evolution. We've just kept adding things to it. But what you're actually pointing out, it's not necessarily obvious so far in this conversation, is it's a complete reversal of the cause and effect.
Indeed.
Of the way people think about evolution, because evolution is always described in textbooks and television shows and everything as evolution through natural selection, but that's actually backwards. It's actually natural selection through evolution. And evolution
can't have the natural selection without the variation.
Right.
And then the big question is, what are the causes of that variation? Is it entirely the genes, which is the standard theory?
Yes.
Right.
Or is it that many other processes are involved as well? That's where the debate is now.
That's right. And so when you're observing that we now know about exosomes, and we now know that that changes in the physical body can then be transferred to the germline.
Yes.
That is radical. Now,
Indeed so.
the best example I've ever heard of this, I have a friend that I'm pretty sure you know, John Torday.
Oh yes, indeed. Yes.
He's been studying for 30 years the effects of secondhand smoke on children.
Right.
So we had lunch one day, and there's 300 different effects of secondhand smoke. And he said, would you like to guess what the number one effect is? And I said, I have no idea. And he said, it is epigenetic changes in a child from a smoking grandmother. Okay, so let me take that apart.
Okay.
So
That is quite interesting.
So a woman smokes. Her body develops all kinds of physiological responses to protect itself from the smoke. Those get passed through the egg, those changes that are contextual. They get passed to her daughter, who passes them again through the egg to the granddaughter. So now the original woman who smoked very well may have died, may have never met the grandchild, and the grandchild theoretically could have never even been in a room with a smoker, but the granddaughter has asthma that she inherited epigenetically from her grandmother. And now this is a radical change in how we understand of evolution, because, for example, Hawaii has 10,000 species of insects and 9,700 are unique to Hawaii. Well, it's not because God sent 9,700 unique species to Hawaii, and it's not because natural selection all by itself just did this. It's because 24/7 very subtle changes and adjustments in the physiology are, in some cases, being passed to the offspring, and that this has been going on all over the ecosystem for 3 billion years. And so when people talk about evolution as being constantly adapting, it's like people sort of intuitively know this, but generally it's never been verbally recognized for what it actually is.
Generally recognized largely because the person who originated these ideas, that is Jean-Baptiste Lamarck, the great French evolutionary biologist, was rubbished.
Yes.
And that is the dilemma we face today.
Can you expand on that? Explain how his reputation was handled.
Well, his reputation was rubbished right at the time of his funeral.
Okay.
Lamarck died extremely poor. He was given a pauper's burial, thrown essentially into a lime pit. And what was read at his funeral was an oration that was written by his great opponent on evolution, that was Cuvier. Cuvier thought that there were separate periods of creation. That was his way of explaining the fossil record, you see.
That's rather like Marx's stages of development,
something like
which was quite a common way of explaining history, actually.
Exactly,
in those days,
that's right. Big sort of
in step changes,
which is not actually totally untrue. I mean, there is, of course, a proper theory. It was Gould who developed it, of the saltationary form of evolution. So Cuvier was not entirely wrong, but he was deliberately attempting to denigrate Lamarck. And at Lamarck's funeral, this oration, which echoes down the centuries, because you can still find it online today, and see how Lamarck was denigrated even at his funeral. That's the big problem.
So that can be your next big task, I think, is to rehabilitate. We're already talking about rehabilitating Darwin, aren't
Yes.
we? Because we think
The
that
real Darwin.
Right.
Darwin has been
Yes,
trounced
absolutely.
and trashed.
The real
and actually,
Darwin.
sitting here,
Yes.
you do get a much, I mean, the sun has come out as well, you get a much warmer feeling about the all-roundness of Darwin.
Indeed, so.
And rather than the kind of
Yes.
narrow,
Yes.
progressive natural selection theory that kind of emerged.
Exactly, but it's also a
Directional.
form of rehabilitation
Exactly.
of Jean-Baptiste
So,
Lamarck.
but then you've got
Yes.
this. I think this is
Yeah.
more, even more special, because there'll be lots of people in rehabilitating Darwin.
Yes.
But perhaps you're the first person to really focus on the neglect of Lamarck. And we actually talked about that it might be politically relevant.
Yes,
he was
exactly.
out of favour.
He was out of favour.
And then in a very disrupted, but essentially leftist century.
He lived through the French
It would have been
Yes.
quite.
But anyway, a last word from you, Perry.
Well, can I ask you another question? Because
Yeah, by all means, yes.
So Darwin believed that acquired characteristics could be passed down, just like Lamarck did.
Yes.
He got the idea from
Yes,
Lamarck.
indeed.
And then that was almost like erased, or was like, oh yeah, well, Darwin had it mostly right, but he got this wrong, and now we know better. And then that became the standard evolutionary theory for almost the whole 20th century. Can you explain how that ended up grossly distorting Darwin's true legacy?
The key to this is August Weismann. He was a geneticist from Germany who in 1883 gave a lecture which has also echoed down through the next 100 years or so. And in that lecture he said, I have noticed that Darwin, I'm paraphrasing, I don't use the exact phrase, but he said, I've noticed that in his Origin of Species, Darwin has several places where he clearly assumes the inheritance of acquired characteristics. I think that is entirely wrong, because there is no way in which the germline can be receiving any information from the rest of the body. How did he know that? He didn't know that. He said it was necessarily true. This is strange for a scientist, but that became the foundation stone of the modern synthesis, or neo-Darwinism. When the great...
There's a barrier.
There's a barrier, the Weismann barrier. Yes, well, that barrier has now been completely passed through by what we now know can pass down to the germline. But I think that what then happened was that people thought, well, it's a terribly simple theory. It was almost like the Occam's razor argument, you know, don't complexify beyond where you have to.
Yeah.
Now, that's sometimes a very useful process in science, but I think in this case it was the great mistake. The mistake was August Weismann.
Well, so where we're at now,
Sorry.
well into the 21st century, is we can now edit genes as easily as a blog post. And there's all kinds of genetic engineering going on.
Exactly.
And what has been drilled in everyone's heads for the last 100 years is that it's just natural selection. Nature doesn't have any other particular direction that it's trying to go, and that acquired characteristics are not inherited. And we find out this is wrong. Of course, you get into how this actually works. It's exponentially, extraordinarily complex.
Indeed.
But there's a lot of scientists that are assuming that we are smarter than this process, and we are not. And we could be on the cusp of making some very, very large irreversible mistakes if we don't have the kind of humility that Darwin
exactly so.
himself had.
Yeah, that's right. So we're broadcasting this from the very place where Charles Darwin wrote his Origin of Species and many of his other books, Downe House in Kent in England.